Okay, I'm gonna do this one without my calculator. Okay, so the first thing I noticed is it's cubic, so I should have an idea of what that looks like. Cubic shape. Maybe some of you have already written it on your cheat sheet. So a positive cubic should look like that. How many possible times could it have x-intercepts? How many possible? Not necessarily how many it has, but how many could it up to possibly have? 3. It could do 1, 2, 3, yeah. What is the value of the y-intercept? Just like that, fast. So what is a y-intercept? If x was 0, if there was no x's involved, what number would you get to? -3. End behavior, it goes from quadrant what to quadrant what? We move from this quadrant, which is quadrant number 3. 1, 2, 3, 4. That's how they would go. So it goes from quadrant 3 to quadrant 1. What's the domain? What's the range? So they're going to be traveling everywhere. How many possible turns could it make? Turns. 2. Yeah. What is a turn? This is a turn and this is a turn. Where you're turning directions. You're going from like an increasing pivot to a decreasing. So it could turn twice. Okay, what is the matching equation? Okay, so if I know that it's traveling up and up, I need something with an even degree, like an x squared or an x fourth. Okay, if they both travel in the same direction, it's even. So this one would just be an x, so it's out. This one is out, it's just an x. This one is out because it would be a cubed. This one is out because it's a cube, x cubed. And this one is out, why? Because it's a negative x squared. So then it's that. Did this one trick you because you don't see x squared in it? But why don't you see an x squared in it? You would have to FOIL it, and then you would see an x squared once you FOIL it, right? What else should you see? You should see a y-intercept of 4 in that as well. Okay, so now functions. We are going to type this into our calculator. Do you remember how? Do you need to write the steps down on your cheat sheet? Okay, so get ready for steps if you are liking to write that on your cheat sheet. How do you enter data? Okay, first of all, entering data. Y equals clear. If we enter data, we're going to have to activate our plot system. So I'm going to pause every time in case you're writing this down. To enter data, Y equals clear everything out, but activate your plot. Good? Stat edit. Up, clear, down. Up, clear, down. Okay, good. How do you do this nicely on a window? What's a fast way to do this one? Zoom 9. Zoom 9 does your statistics, which is what you did. And some of them ask you to do a scatter plot. So what does a scatter plot look like? It means kind of draw what your calculator shows and put the variables on your axes. So now we would need to do number of bikes was my X. Floor space was my Y. So it says a linear regression. So does that make sense? Does your pattern look like it'd be a line? Okay, how do you get that? Stat, calculate. So this is number 4, linear. Don't forget, there's one called ln down below. That's different. There's another one that's different, but you want number 4, linear, ax plus b. Okay, I'm going to skip question B and we're going to answer C. We're going to answer questions. So before I answer questions, I need to put that line into my graph. So do we remember how to do that? Y equals, I need to copy and paste it. So what button do I copy and paste with? Vars, statistics, regular equation entered into there. Cheat sheet people, so what was that? Vars, stats, equation. Copy and paste, equation. Okay, if I'm going to go find data now, it won't work unless I deactivate the points. I want to deactivate the plot. Okay, so I needed the plot to show my points, but then once I got the line, I actually want to deactivate that. Okay, just remember your brain might be having brain farts during the exam, so it's not a bad idea to write all these instructions down in case you forget your button, because then I can't help you. Okay, so here's what we're doing. We're going to estimate the number of bikes. So estimate, we want to figure out X when we know Y is this. So what do you do again? So this is, what is the X if we know the Y? So what's the strategy? Y2. Okay, so you're trying to estimate a number of bikes, so then you can do a rounding number hole on that one. Okay, everyone was good with the buttons? Okay, Ida hit a golf ball from on top of a hill, and it was modeled by this equation. So can you visualize somebody hitting a golf ball from the top of a hill? Okay, so they're on a hill, they hit a golf ball. What would a golf ball do? It would travel up, and then eventually what would it do? Hit the ground, right? So kind of using your knowledge, kind of how did you know that? Well, I knew it was a negative squared shape, right? Negative x squared. Looks like that. Okay, so now let's talk about the y-intercept. What does it represent? So right here, that's the y-intercept. What is the number without your calculator? What is it? It should be 11.5 is my y-intercept. What does it represent in this scenario? Where she hits the ball from, how high is the hill that she's hitting it from, something like that. So obviously if this was on a calculator, do you all understand that it would give you the whole thing, right? It's not stopping. So it says the roots to these equations, so that's the roots, are negative 0.2 and 5.2. What do these points represent, if anything? What did you say, time? Is that what you said? Yeah. Time of what? This one would be time it would hit the ground. What about the other one?
The other one doesn't matter in this situation.
The other one doesn't exist in this scenario, right? Can't have negative 0.2 seconds of time. Okay, so obviously take what's on your calculator, but piece together what is it meaning in real life. Some of it might not exist. Which exponential function is below? So all of these match the decreasing because they all have a base, 1/6, 1/4, 1/5, 1/3. They all have a base that's less than 1. So they're all going to decrease. So that doesn't really help us. They're all decreasing. What's the y-intercept? Maybe that would help us. 3 there and 4 there. So then, did you start at 4? And was your next amount a quarter of the previous one? We went from 4 and then we went to 1. Did we go a quarter of it? Yeah. We went from a population of 4 to a population of 1. That's a quarter of the population the next day. decreasing. Would this one match? Did you start a population at 3 and the next day it's 1/5 of the population? Yeah. Okay, bird population modeled by an ln function. So we're all going back to y equals do you know what an ln function should look like? Do you know what it should look like? Did you write that on your cheat sheet? An ln function. This is just a ln x function. Before you graph it, do you remember what the shape is? Should look like that. So you should see something like that. Okay, what do we know about this? ln functions don't increase very fast. So we probably don't need much number on the y, but we probably need a big number on the x, but they don't increase very fast. This 250 is giving me kind of a hint. I'm thinking I want to do x big, like 500. Oh, maybe not. Nope, I did mine the opposite way. Try my idea the other way around. You know what would have helped if I read the question? Time is the x. X is the time. And then y is the number of birds. So I guess I probably don't need time big. I probably need number of birds to be bigger. Does anybody know where to kind of cheat, bless you, if you want to see your numbers and see how big you want to be? You can always go to the table and then look at my values. When x was 5, I was already at 400. So then the table helps me figure out my window.
Where are you typing this information?
My window.
No, like the.
Were you looking for the table? Like,
In the table, it just kind of tells me what my numbers are, and so then that kind of helps me say what should I put my window at.
But where do you put like the 250 for like the birds?
So here, like looking at my table, when x was 10, there was 10 years, there was almost 600 birds. So then I'm thinking my window, I want y to be kind of big.
Yeah, well, I understand why, but where are you putting? Don't you have to put like y equals or y1 or y2?
I don't know yet. I haven't even read the question. I'm just trying to graph it.
Oh.
Okay, does everybody have a good, clear understanding of the graph from their window? Okay, is the bird population increasing or decreasing? It's increasing because it's a positive ln function. ones increase. They increase slowly, but they increase. Estimate the bird population in 2010. So is this an X or a Y? This is time. So it is X, but please don't type in 2010. Because go back to the question. X is the time in years after 2000. So then this would be a 10. Okay, do you remember the question on your test that a lot of you got wrong? Because I told you X was the number of hours since 8 a.m. or something like that. And when it was 10 a.m., you guys were using X of 10. So what should you have used on the test question?
X of 2.
Trace 2. Because if I say X was the number of hours after 8 a.m., now it's 10 a.m., you got to figure out that that's an X of 2. Okay? That was a test question that was a majority making errors with just that understanding. So what's 1 p.m.? If it's 8 in the morning, and now what's 1 p.m.? An X value of 5. Okay, number of population of frogs. So let's go through this again, how to type all this in. Okay, I'm not going to instruct you. Let's see if you can figure it out on your own. Okay, so the steps that I did was y equals, got past stuff out, activated my plot. I did a stat edit, I put the info in, and I zoom 9'd it. The pattern, I stat calculated, and I went all the way down to ln regression. Got my equation. Okay, then you should be copying and pasting it. So y equals vars, copy and paste the equation. Deactivate plot. Got that all down pat now? So if you ever were to draw this, you would need your variables. So what do you want to put as your x variable? Years, and then number of frogs is the y. So estimate how the population will increase from the 7th year to the 10th year. So I'm going to need to do a trace 10 for that number. And it did this to me. So I was there and I just did trace 10. And it did this. Expand my window. That's why it's doing that. So if I go to my window, quit, and you go to your window, it only went to 7.6. So now make it something beyond 10 so that it will work. Okay? So if you run into that problem, you got to recognize that problem. So trace 10. Okay, so I think on the exam, if you had something like this, there would be 2 separate answers I would accept. I would accept if you used a trace 7 number, which is 225.62, I would also accept it if you used the given number. So you could have just used this one, or you could have used your calculator one. Okay? And then how did it go up? So you would just subtract. Okay, so it was increasing by, I don't know, you could just say approximately 7, went up by 7 frogs, something like that. Thank you. Okay, let's do another sinusoidal. Okay, we are given the equation where this is the height of the gymnast and t is the time in seconds. Okay, we need a y equals. So I'm typing it like this. This number is pi over 2. There's a pi over 2 in front of a multiplier x. Be careful with brackets. That's the stuff that can throw you off. What do we need to recognize with our calculator when we graph sinusoidal functions? We wrote this down on our cheat sheet. Graphing sinusoidals, what do we have to be careful of? Mode, your mode. So I need to be in a radian mode because I could see here this is all radians. Like I can tell with the numbers if there's small numbers, decimally numbers. If there's like 45 or 360 or 180 in there, then it's degrees, but this one is radian mode. So you have your mode in radians now? Did anybody try a Zoom 6? Are you getting something like that? Okay. Would you understand that this part of the graph? Nope, not going to work because I can't have the negative time. Also, this is a gymnast jumping. This part of the graph doesn't really make sense. I'm not going to jump under the ground. Okay, so what's happening? the gymnast is probably doing a floor routine and then does what? Starts the jump and then they would land, right? And then they do their floor routine and then they jump. And then they land. Okay, so that's what's happening. So I need you to, A, get me the max height. So you can pick whichever bump you want to do. I need a max height. And I think I want the time here and the time there. And then I'm going to subtract that to say this is how often they're doing it. So those are the things you need to figure out how to do on your calculator. Oh, did mine wrong. Could be on a trampoline.
That's what I was thinking.
21.3 feet.
Yeah, that's what I got.
I did not get that either.
Yeah.
I got 2.76.
Yeah, that's what I got. 2.76.
Which actually.
But this is the middle. This is the middle, and then you're 11.5 feet on top of the middle to be your max. Remember, like that kind of stuff. The mid of this would be 9.8. The top would be, if I add 11.5. And then the bottom would be negative 1.7. Oh, you know what I did? I typed this in wrong.
It should be pi x, right?
There.
Okay.
That's,
I think you get the same thing. I don't.
Okay, this looks a lot.
sorry. Yeah, that's, I had done that wrong in my calculator too. I'd put the bracket on that, but it's not. So we're gonna say we're on a rebounder trampoline.
Yeah. Somebody jumping 21 feet with no trampoline, that'd be crazy. Even on a trampoline, that's crazy.
Yeah.
Have you seen trampoline? No, I haven't. It's crazy. I'll look it up this weekend. Yeah, look it up. They jump that high.
Did anybody get your X numbers yet?
Yeah, I got 4 seconds. It was guy then boy.
Oh, you got a.
I got equal numbers. Yeah, that's still a difference of 4. I just found the maxes.
You just did the maxes.
Yeah.
So this one I got a 3.35 on, and then the next jump I got a 7.35. So every 4 seconds, this gymnast is jumping off the ground. So
What did you do to find the every 4 seconds?
I did calculate the 0, and then I did a left and a right, like that, if I was zoomed in. So this question on your exam might ask you, when does she make the third jump, or something like that. So this was the first jump. This was the second jump. So I would just add 4 seconds. So it'd be 11.35 is the next jump, or whatever. Maybe my pre-calc brains might have done something different to get that number. That would be like the very applied way to do it. What would my pre-calc brains maybe done? 2 pi over the b. And what is the b? This is the b. So 2 pi over 2 makes 4 seconds. Okay, this is a bike wheel. Okay, so let's practice typing. You would actually need double brackets like that in your calculator. So let's do a practice again, because these ones are tricky. Do we look the same this time? Radian mode again, and the hint was all these decimal numbers. That's a radian language. Bracket, bracket.
What is your window? Oh,
My window,
Wait, how do you insert something again?
you do second delete. Second delete. Cos, and then it gave a bracket, and then you do a 4.6 bracket x plus 1.7 bracket bracket. I went up to 80. I went up to, yeah, 75 would work. And I went up to 5 seconds on that one. Okay, does everybody know how wheels work? So I've given you lots of wheel questions before. Wheels are always sinusoidal. Okay, what are you when you're at the bottom of the wheel? What's your height at the bottom of the wheel? I hope your bike is on the ground. That would be good. What's your height when you're in the middle of this wheel? What's the middle? 34. This is the middle, and this is the amplitude. So if we go above the middle by 34, what are we at? 68. So what is the whole diameter of the wheel? Diameter equals 68 centimeters. Okay, I like this question because we're going to put some design measurement into this problem solving. You ready? It's going to get problem solving on you. How long does it take me to go around my wheel? Do you want to do like a top to a top, or do you want to do a 2 pi over b? Okay, so 2 pi over b. 2 pi divided by 4.6 is 1.3. Oh, you know what? I'm going to go a few decimal places here. I don't like rounding. That's how long it takes me to go around an entire wheel. Okay, now here's what I'm going to do. The distance I travel on a wheel is all the way around the wheel. Do you know a mathy term that tells me all the way around a wheel? Circumference. Does anybody know that formula? Two pi r. Yeah, did you know that? It's hidden somewhere on here. The only spot you would see as circumference is right here. Pi r squared is area. 2 pi r is a circumference of a circle, because you can do a circumference of a cylinder. That part of it, yeah.
So what did we figure out the 1.366?
That is the time to go around once on a wheel. That's the period. 2 pi over b is the period on a wheel. A period is once on a wheel, right? So 2 times pi times, what is the radius though? 34 is the radius, right? 2 times pi 2 pi r So how do I get a speed if I went this far in this many seconds? How do I do it as a speed? This many centimeters per second. I'm not going to do any rounding here, actually. And you know what they also did to you? Why don't we just make it more confusing? Meters per second. So see how there's problem solving, there's measurement, there's everything in this question. This would be something probably not given to you. Centimeters, meters, you gotta know some of the life skills here. How many, you have a whole meter, how big is it in centimeters? 100. So would I times or divide that number by 100?